neutral.
Yeah, neutral. I don't really care because it's not going to change my life. But anyway, David said he has a reason why.
That's the one thing that triggers me. When someone says, what difference does it make? It's not going to change my life. It's going to change your life.
Hear what you have to say on
it's
that.
going to change your life.
Yeah, okay, cool. That's awesome. So I like to learn new things. Okay, so I observe the hell out of nature, okay, especially being here in the sun in Mexico.
Nature doesn't
lie.
And
when you're at high noon here on the beach, and I put my hands up, and I know there's obviously light refraction that plays a role into all this, but when you're putting your hands up above to block out the light, to look at the sun, to me anyway, from my perspective, I see the sun as a specific size. And then on the top deck of my casita, I have a fourth spot where I can go up there and I can watch the sunset. And to me, the sun is bigger as it comes down, what it appears to be going below the horizon than above. Now, if it is going straight across the earth, then to me it would be the same size, and it would get smaller as it moves away from us, and that just is not what has happened since I've been observing it here.
And that's because you do not understand what you're seing. And tonight I'm going to teach you all what you're seeing.
Cool.
Okay,
awesome.
So I'm going to show you guys two tables. Are these the same width and dimension?
Well, I know.
You know.
Yeah, no, I've watched your stuff.
Okay, so again, so your eyes, it's very difficult. So this is just showing you that unless you can touch it and measure it, you can't really tell. So first, let's you guys, you probably have seen this, but I want to show it again because then I'm going to lead into something new that I'm going to show. Have you seen my flat Earth kitchen? Seen this?
Yes, I've watched your video on this.
Just real quick so people can see it. We're looking.
This is for our guests for sure.
We're looking at the sun from the elevation of the sun. This line is level. Yes, it's level. I verified it in the full video, but you can see that it's level. Here's my counter. Here it is moving along. This is it can be a cloud deck or a mountaintop, whatever. It's opaque and it's above it. Now we're going to look at the view of the same path from the table, from the far end of the table, and look at the line. It looks like it's going down. If I showed you this first and said, is this line level? You would say, no, it's going down. And look, it never went below this, but this is from the viewer's point of view at your eye level. This is compressed into the horizon. Look at the line now. It's almost going straight down. Okay. So this is just without any atmosphere, refraction, magnification, nothing. Okay. Now we compare it to a real sunset, and look, it goes behind, this is the real sunset, an atmospheric deck. So this is that cardboard bottle thing I had, right? Yep. But your eyes can't see the difference between that line and the apparent horizon, and it all crunches together and it all just disappears beyond this cloud deck, atmospheric deck of opacity. So now we're going to talk about perspective. So when you watch something go away, it gets smaller. Bam, it just goes away and it gets smaller because you are at the same level as that thing. As it goes away, it gets smaller. Nobody disagrees with that. So this is perspective, and it literally goes away until it disappears. Now these lines are all level, but look at these lines here. These are almost going straight down. Okay, this is a hallway. And it's level, but your eye perceives these as going down. So here we have a sun that's already elevated. Okay. It's really going straight across, but due to perspective, it goes down. And this is what an observer would see. This is like a cross view of it. And this is what you would see. So this sun is just going down due to perspective, like I just demonstrated. Okay. So I forget what the name of the effect is. So here are the train cars. It's already reduced.
Yeah.
And as it goes away, it really doesn't change size very much. So this is a cartoon. Let's look at it in reality. Here's two balls, okay, that are the same size, 6 feet apart. The one in the distance is way, way, way small. Okay. So we have a camera looking at it. One's very close, one's very far. It shrank already, as things do as they go into the distance. But when we lift the camera up, straight up, not getting any closer to the other one, watch what happens. Okay. Because when something is already away from you, its perspective drop gets less and less. And at 7 feet high, they're pretty much the same size, right? So if I move this ball along the track, it's not going to get any smaller. And perspective tells you it's going down. Okay, this is all just a trick of the eyes, and that's how it works. Now, here's another thing. There's two more things I'm going to tell you. One, as that sun is going away, as it becomes lower and lower, you're looking like when you're looking at the sun above you, you're looking through just a little bit of atmosphere. But when you're looking at the sun away from you and it's already dropped, you're looking at it through all of the atmosphere. And when you're looking out over water, there's moisture in that air. So as the sun is going away, remember, it's already up. It's not going to get much smaller. It's also being magnified a little bit sometimes, not every day. That's why sunsets look at different sizes on different days. Okay. It's called atmospheric magnification. That just plays a little part. And then the last thing is it's really not bigger. When you see the next time you guys have an opportunity to see a moonrise or moonset that is gigantic on the horizon, well, you go, wow, that's big. It's not. It's the same size as this one above you. And the way to do it, you know, you think like, wow, look at that moon. You take a picture and you look at the picture and go, well, it's tiny, right?
Yeah.
But you look at it, it's gigantic. It's your mind. Here's what you do. Sounds gay. It's not. Turn around, spread your legs, bend over, and look at the moon upside down through your legs. And it will be tiny.
You're kidding me.
It will be tiny.
Why?
Because your brain short circuits and it can't.
Oh my God.
It's totally a short circuit. It's the way we see things. We don't see. Yeah. So the whole argument of the sun not getting smaller, and by the way, it does get smaller many times. depending
I'm
on
gonna
the.
try it out later.
Yeah. Is it a full moon?
No, it was a few days ago.
Yeah. So, well, it might be big enough. But this was taken by a soldier in Afghanistan. Super dry, not over the water, and no humidity. And the sun just goes away. Paul McCartney knows the fool on the hill sees the sun going down, but the eyes in his head see the world spinning round. And this, look, we are spinning backwards at 1,000 miles an hour.
Yeah.
Why isn't that sun going down? It's just going away, and it's getting smaller and smaller and smaller until you can't see it anymore. Okay? So it's all nonsense. Next.
I love this guy.
That was a good explanation.